Hi everyone, welcome to this lecture. So in this lecture, we are going to learn about another loss function, which is cross entropy loss function. It is also one of the most commonly used loss function in neural networks, and it is used when we have to perform classification with the help of the loss function. So previously we learned about MSE loss function, which is mostly used in regression applications. So cross entropy loss is mostly used when we have to perform classification with the help of neural network. So before going into cross entropy loss, we have to understand the concept of a negative log function. If we see here, this is the plot of a negative log function, where on x-axis, I have a value of x, and on y-axis, I have a negative log of x. So if we see here, we can see that if we increase the value of x, the value of negative log x decreases. So this is very important property which we will use in order to understand the concept of cross entropy loss. So we can see here, if x is equals to 0.03, that is very small value of x. So we are somewhere here. If x is equals to 0.03, we are very close to 0. In that case, the negative of log x is 3.5. So if x is very, very small, we can see that the value is large, that is 3.5. Similarly, if we increase the value of x and now we are at 0.9. So here x is equals to 1 and 0.9 means we are somewhere here. In that case, the value of negative log x is very small and it is approximately equals to 0.1. So we can see that if we increase the value of x, the value of negative log x decreases. So this negative log x is high for the small value of x and it is low for the large value of x. Now this is the equation for the cross entropy loss. So here we have few important parameters or variable in this equation. So first variable is y. Y is actual class label or it is ground truth. P is the predicted probability for the class. That is, it is the probability of the class which is predicted by the model. Okay. N is number of samples. Here N is number of sample and C is number of classes. So this is cross entropy loss. So it is based on the logarithmic value for the probability of the class predicted by the model. So this is called binary cross entropy loss. So cross entropy loss becomes binary cross entropy loss if we set number of classes is equals to 2. So for 2 classes, this is the form of BCE or binary cross entropy loss. So here we can see that we have 2 terms. This is first term and after the sign of addition, this is second term. Here we have y and here we have 1 minus y. Here we have probability P and here we have probability of 1 minus P. Now for simplicity and for better understanding, suppose n is equals to 1, that is we have only one sample. So if we have only one sample, this is the form of binary cross entropy loss. Now again, we can see that we have 2 terms. Here we have a negative sign, but we have a 2 terms. That is, this is our first term and this is our second term. Now the important thing is that we cannot use both terms simultaneously. That is, if y is equals to 1, we will use this term to calculate the loss, and if y is equals to 0, we will use this term after this plus sign in order to calculate the loss. Now, how it is happening? So basically, if your label is 1, because we are doing the binary classification, in that case, we have 2 labels, that is 0 and 1. So if your y is 1, if your label is 1, and if you put 1 in both of the terms where y is present, then this term will be 0. The second term will be 0, because if I put y is equals to 1 here, then 1 minus 1 is equals to 0. That is, this term will not be used to calculate the loss if y is equals to 1, and I will use only that term. That is, if I put y is equals to 1 here and y is equals to 1 here, this term becomes 0 and I will get only negative log of p. So that is the equation of binary cross entropy loss if my label is 1. If my label is 0, that is y is equals to 0, and I put y0 here and y0 here, then due to 0, this term becomes 0, because if I multiply log of P with 0, I will get 0. But if I put 0 here, then I will get 1, because 1 minus 0 is equals to 1. So that term will be used as calculation for the loss, that is for binary cross entropy loss. So we have observed that in our binary cross entropy loss equation, we have two terms. So the first term will be used when y is equals to 1, and the second term will be used to calculate the loss if y is equals to 0. So this is the form of the first term when y is equals to 1, and this is the form of the second term of this equation when y is equals to 0. Now, there are three cases. Now, case one is when loss is high and need to minimize. So the question is when the loss is high. So here are the two situations where the loss is high. If y is equals to 1 and the probability of prediction is 0.1, in that case, we will use this part of the equation in order to calculate the loss, that is minus log of pi. We have seen this in the previous slide. So if y is equals to 1 and P is equals to 0.1, in that case, our loss is negative log of 0.1. And we know that if inside the negative log, we have a small value, then the negative log is high. So if y is equals to 1 and P is a small value, in that case, loss is high. The other possibility is if you have a second label, that is y is equals to 0 and P is high, that is 0.9. In that case, we will use this part of the equation in order to calculate the loss. Okay, so if your P is 0.9 and you put P is equals to 0.9 here, you will get minus log 1 minus 0.9. This again will become log of 0.1 and this value again becomes high. So here are the two situations with y is equals to 1 and y is equals to 0 when loss is high and we need to minimize. So the loss is high because loss depend upon the negative of the log. So if there is a small value in the negative of a log, we will get a high loss. Now this is the situation when loss is low. So when loss is low and your label is 1, that is y is equals to 1, in that case probability is 0.9. And a negative log of 0.9 is a small value because we have learned if a large value, because this is a large value as far as the probability is considered. So this value is large and we know that if we pass a large value to negative of log, it is small. It will give us the small value. Similarly, if y is equals to 0, then we will use this part of the equation in order to calculate the loss. So here y is equals to 0 and P is equals to 0.1. So if you put P is equals to 0.1 here, then you will get 1 minus 0.1, which is also equals to 0.9, and we will get the low value of the loss. This is the ideal scenario. So if y is equals to 1 and P is also 1, then minus log of 1 is equals to 0. And similarly, in the second case, if y is equals to 0 and P is also 0, then negative log 1 minus 0 becomes negative log of 1, which is equals to 0. So these are the three possible cases which appears with the cross entropy loss, and cross entropy loss depends upon the negative value of the log. So in that case, since we have a concept that if we have a small value inside the negative log, it will give us a high value. So in this lecture, we learn about the cross entropy loss. In order to make our understanding easy, we convert the cross entropy loss into binary cross entropy loss. We saw that the binary cross entropy loss has two terms, and we cannot use both terms simultaneously in order to calculate the loss. If our label is 1, then we will use this term in order to calculate the loss, and if our label is 0, then we will use the second term of BCE in order to calculate the loss. So I hope you understood this lecture. You understood how cross entropy loss works, and it depends upon the negative log of the value. Thanks for listening, and I will see you in the next lecture.